Hello, welcome to the data visualization class. In this tutorial, we are going to learn how to use Python visualization tools to analyze numeric variable. Let's start with a real-world task. Suppose you are a data scientist and you want to analyze student performance and provide insight for a certain education organization, and you collect a data set about students. And this data set is about student characteristics and their performance over different subjects. Let's first take a look at the data set. The data set includes 8 columns: gender, ethnicity, parental education, launch test preparation course are the categorical variables. Math score, reading score, writing score represent student academic performance, and they are numeric variables. In the previous tutorial video, we talked about how to use data visualization tools and to analyze categorical variables by creating bar chart and pie chart. In this tutorial, we are going to focus on the numeric variables, the last 3 columns. And we're going to solve the following question. What is the distribution of math score? What is the distribution of math score across gender? What is the distribution of math score across ethnicity? And what is the relationship between the math score and the reading score? So let's open a Google Colab, and we can first upload the data set and start to analyze. So I'm going to go with this file folder, and under content, I'm going to upload the data set I need. So we're going to analyze the student.csv. So this is the student.csv, and after I upload the data, you can see that data is located under the folder content. And then I can import some libraries. First, I'm going to import pandas SPD, and then I'm going to import Seaborn as SNS. This is our visualization library. And finally, we're going to import matplotlib. Import pyplot as plt. Okay, then run the code. Okay, first we're going to upload the data set and read to the Python notebook. So I'm going to define a data frame called df, and that equal to pd.readcsv, because our data file is a CSV file and it's called student.csv. Okay, and then let me check out what is the first 5 rows of the data set. Okay, now you can see that Python gave us the first 5 rows of the data set. The data set looks like this. And the first task is to analyze what is the distribution of the math score. So in order to analyze the distribution of math score, we can use a histogram. And a histogram is a visualization tool to display the distribution of a certain numeric variable. And our math score is a numeric variable, so histogram is perfect to display such a distribution. So in order to create a histogram, I'm going to use sns.histplot. So this histplot function helps us to create a histogram. First of all, we're going to tell Python which data set I should analyze upon, and that is a df. This is our student.csv. And then I'm going to specify which variable I should visualize upon. And the variable is a math score. So I'm going to copy this target variable and paste in here. Okay, so that's all for, that's 2 fundamental arguments I can put inside of this function. And then I will say plt.show to let Python show the results, and then run the code. Okay, now after you run this code, you can see that Python create a histogram for us. and the x-axis represents math score, and the y-axis represents the count. From this chart, we can see that in this data set, most of students have a score from 60 to 80, right? They are accumulated in this area. Okay, now I can improve this history plot a little bit. So I'm going to copy these two lines and paste in here, but in this function, I would specify another argument that is called KDE. And for KDE, I would set that to true. So what does this mean? KDE is short for kernel density estimate. So basically, you can think of the KDE as a smoother version of the histogram. So let's take a look at what happened if I add this argument. Okay, now once you add the KDE equal to true, you can see there is additional KDE kernel density estimate curve for the math score. So that means you transform this math score to a continuous variable and plot that into a Python notebook. So that is how this KDE is applied. Okay, next question is, what is the distribution of math score over different gender? As we can see in this data set, we have a different gender, right? Boys and girls. So the question is, different gender may have different math score distribution, and how do we use Python visualization tool to tell that pattern? In order to do such, solve such problem, we can use histplot again. And inside of the histplot, I would add another argument to specify the gender difference. So let's take a look at how this can be solved. First, I would say SNS histplot. Okay, that is our function. And in the histplot, I'm first say the data equal to df to tell Python the df is a target data set we should analyze upon. And then x-axis equal to math score. So this is the variable that we should set for the x-axis. Okay. Then I would also specify KDE equal to true because I want to take a look at the smoothed curve line for this math score variable. And next, this is interesting. I want to add another argument called hue, and I would set hue equal to gender. So what does this mean? If I set hue equal to gender, I would tell Python to further split the original math score distribution into different gender. And we set for each different gender label, I would set a different color. We know that gender have a female and male, right? So we further split the entire histogram into two sessions, and each session represent male and another session represent female. Okay, that is a hue. And then let's take a look at what happened. plt.show. Okay, now this is what this happened. The original math score distribution would be further split into two sessions. One is for females math score, and the other one is for males math score. And take a look at the position of the females math score distribution and the males distribution. We can see that for male student, the middle line, the average, is slightly tilted to the right. That means for the male student, their math score is a little bit higher than a female student. Okay, now how do we change the color? Because right now, female is represented as blue and male represented as orange. If you want to change the color, you can type palette So this palette will specify the different color to different label. And then you can use this bracket. And in the first bracket, it represents the female, right? So I'm gonna use light pink to represent a female student, and we're gonna use blue to represent male students. And let's rerun the code. Okay, that is better, right? So you can see that the math score is split into females distribution and males distribution, so that you can analyze how this math score is distributed differently according to different gender. Okay, next we want to analyze what is a math score is distributed over different ethnicity. In another way, I want to visualize this numeric distribution over a certain categorical variable. I can use a box plot. Okay, in order to create a box plot, I can use a cat plot. So that being said, I can use sns.catplot, and this cat plot represents a categorical variable plot. And first, I'm going to specify which data set I should analyze upon, and then I would first specify what is the x-axis. For x-axis, I would want to use ethnicity. Okay, because I want to take a look at how this math score is distributed over different ethnicity. I want to set ethnicity as x-axis. However, you can also set ethnicity as a y-axis. It does depend on your preference. And for y, because I want to connect the ethnicity with math score, so I'm going to set y equal to math score. Okay, and that is not complete. The final argument is a kind equal to box. When I specify the kind equal to box, I basically tell Python to create a box plot to show the connection between the ethnicity and the math score. And then let's take a look at what happened after I run the code. plt.show. Okay, if I run the code, you can see that this is a box plot over different ethnicity. Ethnicity is from group A, B, C, D, E, right? However, the box plot this box represents the middle 50, and the horizontal line here represents the median. And from this graph, we can show that for group A, this group has the lowest median compare of all the data set we have. And for this group, group E, this group student really perform good on the math score, and because the median is really high compared with other groups. Okay, so that being said, the math score distribution is different based on the ethnicity groups. Okay, another way to show the math score distribution on ethnicity can be use KDE plot. Okay, as I said before, the KDE plot represents the kernel density estimate. It is a smoother version of a histogram, and it shows the distribution of the numeric variable. In Seaborn, we have a specific function called KDE plot, and you can use the KDE plot to show the distribution of a certain numeric variable. And let's try this. sns.KDE plot. Okay, inside the function, I would say data equal to df and x equal to math score. So I want to analyze the df dataset, and then the x-axis, I want to set that as the math score because this math score is our target variable we want to analyze. Okay, and because I want to analyze math score over different ethnicity, I would specify the hue. Remember, the hue will further split the entire math score distribution into different subgroups based on the target variable you're gonna put in here, and that is identity. Okay, and finally, we can set another argument called common norm, and that equal to false. So let me explain this common norm equal to false. If I set false to common norm, I would assume that each identity's label is independently distributed. Okay, now let's take a look at what happened. plt.show. Okay, because the identity I want to show its individual distribution of the math score, and then I set common norm equal to false, right? So this is our result. From this result, let's take a look at the relatively position for each group. Let's take a look at the group E, the purple line. The purple line, its position is relatively to the right, right? Their entire distribution is tilted to the right side. That means the group E has the highest average math score. However, for the group A, which is the green line shows, the position is relatively to the left. That means for students who are in the group A, their math score is relatively lower. So this result is correspond to this result, right? The result we created by the box plot. The box plot shows that group E, which is the purple one, has the highest math score. While the group A, the green one, has the lowest math score. And this result is identical to this one, but with different form. This form is the box plot, and this form is a KDE plot. And the only difference is the assumption. And if you assume that your data set, the math score is a continuous variable, then you can use this KDE plot. And if you assume that the math score is just individual numbers in your data set, you can use this box plot. Even though they are different in the form, but the result is the same. They both tell you that different identity has different math score, and the purple group has the highest math score overall, and the green group, the group A, has the lowest math score. So the results are identical. Okay, so this is how we create math score and show its distribution over different identity. And the last question is, we want to show the relationship between two numeric variables. We want to show the relationship between the math score and reading score. So for the students, some students would have a higher math score, and they also have a relatively high reading score. Let's find out if that assumption is correct or not. In order to find the relationship between the two numeric variables, I'm going to use a scatter plot. So luckily in Seaborn, we have a specific function called scatter plot. Okay, and this function can help us to create a scatter plot over two different numeric variables. First one is a df. This is a data set we're going to analyze upon. And for x-axis, I'm going to set that equal to math score. And you can also set the x equal to reading score. That's that equal to you can switch the x-axis and the y-axis. It doesn't matter. And y equal to reading score. This is another numeric variable we want to analyze. Reading score. Okay, and let's see what happened. Plt.show. Okay, so this is our scatter plot. The x-axis represents math score and the y-axis represents the reading score. And from this result, we can see that there is a positive correlation between the math score and the reading score. That means if a student has a relatively high math score, they tend to have a higher reading score. And let's further split the scatter plot into different subsets by gender. In order to do that, remember we can use hue to further split the data into two different sets, and we're going to assign them into different colors. Let's see what if I assign hue equal to gender. When I add the hue equal to gender, I would tell Python to split the data into two subsets. One set is for female and the other set is for male. Okay, let's take a look at what happened. After we run the code, you can see that the entire scatter plot will split it into two subsets. The blue set represents female and the orange one represents male. I can further change the color. Palette equal to, the first one is female because the female label comes first. We're gonna assign that into light pink, corresponding to the previous one. And then we're gonna use blue to represent male. Okay, let's rerun the code. Okay, that is the distribution of the math score and reading score over different gender. And here is a pattern, right? And you can see that for different set of the scores, the female students, those points are higher. The overall female student groups are located in the higher section of the graph, while those blue dots represent the male students are located in the lower section. That means if you have the same math score, girls tend to have a better reading score, right? So that means for the different math score and the reading score, their distribution is kind of different between the female and the male. So from our visualization, we can observe there is an obvious difference between the gender and the scores. Okay, so that is our interpretation, and this is how we use different visualization tools to analyze numeric variable. Thank you for watching.